Hello again, ladies and gentlemen. Welcome back to my channel. This is Math to the Point, and my name is Mr. Arias. In today's class, we're going to learn how to add or subtract fractions that have the same common denominator or like denominators. Now, let's begin. So the only rule that we have is this one that is made up by two steps. Step one is just to basically add the numerators of the fraction and keep the same common denominator for the final answer or the final fraction. And then lastly, there might be an extra step which could be applicable or not depending on the problem, which is to reduce the final fraction if necessary. I'm going to give an example in which this happens and one example in which that doesn't happen. Okay, so let's jump into it. Example one is basically to add the following two fractions. So something to pay attention to is the fact that these two fractions have the same denominator, which is 4. So because of this, we're going to keep this denominator for the final fraction. So the only thing we have to target will be, in this case, the two numerators of the fractions. So all I have to do is add them. So I'll be adding 3 plus 1, which eventually will give me 4 over 4. Okay, and that's it. That's pretty much the mathematical process when you add or subtract any fractions that have the same denominator. However, in this case, we do have that last applicable step, which is the one in which we have to reduce the fraction. So if you notice, we have a fraction that has a 4 and a 4 in the denominator and in the numerator. So we have to reduce the fraction. And that happens because if you notice, we can actually, these two numbers actually have some factors that we can divide them by to reduce this fraction. And this will not really change the answer. It's just going to make it appear smaller than it is. But this is an extra step that you definitely want to make sure you apply if you end up with a fraction that has multiples that can be applied so that we can divide the two parts of the fraction and then reduce them. So in this case, I'm going to play with the number 2 because I can divide 4 by 2 in each side of the fraction, and then we end up having 2 and then 2 in the denominator. Okay, now if you notice, we haven't finished it because technically we can still simplify this a little bit more or reduce it a little bit further. So if I apply the same operation, which is divided by 2, then I can reduce this further, which in this case would be 1 and 1. Okay, so that's basically my final answer. The alternative answer is just the number 1, because if we divide 1 by 1, that's basically just 1. Now, some people might comment and say, hey, can we just not kind of like divide 4 by 4 from this step right here, and then we end up getting just 1? That's also pretty much another alternative method. This one is a little bit more kind of like visual, I guess. So if you want to apply all these steps so that you can get the final answer, that's perfectly fine. If you want to do the little shortcut and just divide 4 by 4, that's okay as well. Okay, perfect. So that is an example in which we reduce the fraction. Now, what's an example in which we do not apply this last step? Let's quickly come up with one. In this case, I'll give you the fraction. Let's see. I'm going to give you, let's make a third. There's a third. Let's make them a third, both of them. Okay. So let's imagine that now we have this example in which we have to add these two fractions. So in this case, what would happen is that we're going to apply the same steps. Step 1 is to add numerators, and we keep the same denominator for the final fraction. So I'll just quickly highlight again the fact that since we have the same common denominator, we're going to keep it in the final fraction. And then all we have to target, like I said in the previous example, will just be the numerators. So I have to add 1 plus 1. And then if I simplify that, I get 2/3. So that's a final answer. Now, if you notice, we don't have to apply the last step because this fraction has two numbers, 2 and 3, which do not have any multiples or factors that I can divide them by at the same time so that I can reduce this fraction. Another piece of information to keep in mind is that you want to make sure that you divide the top and the bottom of the fraction by the same number at a time. So in my previous example, we divided 2 times by 2, but we were dividing by 2 at the same time, the numerator and the denominator. Never divide by different numbers if you want to reduce these fractions, okay? And like I said, because we don't have any same factor or multiple that I can divide the top and bottom by so that I can reduce my fraction, then this will be the final answer, 2/3, okay? And if you're trying to subtract any fractions, ladies and gentlemen, it works the same way. For example, if I were to subtract, in this case, third and third, I just keep the same, I would just keep the same denominator, and then we just have to subtract the ones, which in this case would be equal to 0, right? Over 3, right? And then if you think about it, anything that divides 0 would just be 0. So this would just cancel out and be equal to 0, okay? The other explanation is that if you pay attention to this problem, we're technically subtracting something from the same thing. It's like subtracting 1 from 1. That would be equal to 0. So subtracting 1/3 from a third will also be 0. Thank you for watching the video. I'll talk to you next time. Take care.